All right, so section number 2, we're going to wrap up our discussion of inequalities. So what you need to do first is actually check number 9 and 10 on the bottom of your Reteach 11-4 handout. So you can hopefully check these really quick. Pause the video right now, and that would be a great idea to pause so you can check to make sure these are correct. And now that you've got those checked, let's go on to the next page, and you can check numbers 1 through 8 of your practice B. So pause the video right now and check those and correct them with a colored pen or pencil, please. All right, now we're going to finish up the rest of your reteach where I told you to stop first, and we're going to skip through that. I duplicated some of my stuff here, but on the back of your reteach, you have this section on what's called compound inequalities. Compound just means a combination of two inequalities. And there's two different situations that you could have. One of them is a very realistic, kind of an everyday occurrence, whereas the other one is not maybe as common, but it's still a possible situation in math. So one of the situations could be where we have an AND situation. And the way you graph that is going to look something like this. It looks a little complicated, but it's actually pretty simple. This says two different things. Let me erase this just so you can clearly see what I'm talking about. You really have two inequalities here. You have this one, and you have this one. So your two inequalities are saying that x is greater than, because x is on the open side of your inequality. It's either greater than or equal to -2. And then you also have x is less than or equal to +2. So x is bigger than or equal to -2, and it is less than or equal to 2. So basically that means that x has to be between -2 and 2. So then you have to think, well, could it be -2? Well, this says since it's equal, that means it could be -2. And then could it be +2? Well, if it's equal to 2, then it could be +2 as well. So when you have an x or a variable sitting in between two numbers with two inequality signs that are facing the same direction, that means it's an AND situation. That means this has to be true and this has to be true. It's really just an overlap, because what would happen, and I'll show you on this graph right here, I'll just try to squeeze it in. If I were to graph this, x is greater than or equal to -2, I would put a closed circle on -2 and draw an arrow to the right. And you're going to have to imagine this is a little bit closer. And if I said x is less than or equal to 2, that means I'd have a closed circle on +2, and I'd want every number to the left. Well, the part that I want is what's true for both of them. Well, everything from here to here is on both graphs. That's where they overlap. So from the number -2 down to +2, and everything in between would make this a true statement. So when you graph it, you don't need to graph both of these. You graph closed circle on the -2 to say -2 is an answer, and a closed circle on +2 to say, yep, 2 can be an answer, and then everything in between is a solution or is an answer. So just like this one, the x, the variable, is physically sitting in between -2 and 2. That means the same thing. Your solutions, your answers, are physically sitting in between the -2 and the +2 dot. Okay, so that's an overlap. It's like one of those, you've done Venn diagrams before where you have this and then you have this. So these are characteristics of A, these are characteristics of B, and then everything in between are characteristics of both. That's what this is. This part right here is what they both have in common. So that's the overlap. Our overlap just happens to be on our inequality graphs. That's all that is. All right, so then the other one is really much easier. This is an or situation. So you can have an and or an or. Now, or means these numbers could be answers or these numbers could be answers. And we need to graph them all. So this says that x is greater than 2, so we want all the numbers that are bigger than 2, or x could be less than negative 2. So we want everything smaller than negative 2. So when you graph those, it's going to look pretty much the opposite of what you just did. So this one would be x greater than 2, so you have an open circle on your 2, and then we want everything bigger than that, so we draw our arrow to the right. This says x is less than negative 2, so open circle again on negative 2, and we want everything to the left. Things like this could be something as simple as saying, I can spend $20, but no more than 30. So you're giving yourself a little window. It could be $20 up to $30, or it could be any price in between, and that would be okay. Or you could say, like on a ride, you have to be at least 46 inches, but you can't be over 60 inches to ride this ride. So if your height is somewhere between 46 and 60, you can ride the ride. If you're above that or below it, you're either too short or too tall. So those are some just everyday ideas that go along with that idea. Okay, so what we want to do is graph. They've kind of started us off and talked us through number 7 and 8. So we're just going to go through and graph these. Now, immediately, as soon as you look at this, you know this is an and situation. So I'm going to have a dot of some kind and another dot, and then I'm going to have an overlap. So I just want the overlap. So I know that all my answers are between 0 and 3. So then when you look at your inequalities, this part right here says that x, it's the opening is opening up to x. That means x has to be the bigger number. X is greater than 0. Can it be 0? And hopefully you're saying no, because there's not an equal sign there. So we're going to put an open circle on the 0. See, draw an open circle at 0. Then it says x also has to be less than or equal to 3. So can it be 3? And the answer there would be yes. So we're going to do a closed circle or a filled in circle right there. And then we want everything less than or equal to 3. So we've got the equal. Less than is going to be to the left, but it has to be bigger than 0. So that means when I get to 0, I have to stop. So my line is just going to connect those two dots. So anything above 0 but less than or equal to 3 is my solution, and that's what your graph should look like. All right, and then when we go to the or situation, so it could be, this could be a possibility, or this is also a possibility. You're basically just graphing those separately on the same number line. So if x is greater than or equal to 4, that means I'm including the number 4, and I want everything greater than 4. Well, everything greater is to the right. And then it also says that x could be less than or equal to -1. So if I go to -1, it could be -1. So I'm going to fill in, do a closed circle, and then I want everything less than -1. Well, everything less than is to the left, as always. And there you have it. All right, so there's not a whole lot to that, but it kind of it's a little bit more confusing than what we did before, but it uses the same idea. So what I want you to do now is go on to the bottom of your worksheet 11.4 and graph each of these. Again, you're going to have to fill in your number line with numbers that will be appropriate, and you should be able to fill in everything, and then just pay attention to whether it's an or an and situation, and then what your graphs will look like. So there you go. If you have any questions, let me know. See ya. Wouldn't want to be ya. Ha ha.